Here we have a SAT math question. Okay, let's go the information. X square negative ax positive 12 equals to 0. In the above equation, a is a constant and a is greater than 0. If the equation has two integer solutions, what is the smallest possible value of a? Okay, now we have a quadratic equation. Okay, so if I want to solve this quadratic equation by factoring, what I will do is, I will multiply the constant term positive 12 by the coefficient of x square. Here in this case, it's 1. So when I multiply this constant term positive 12 by the coefficient of x square 1, that is 1 times positive 12 is positive 12. Okay, now what I have to do is I have to get two factors for this positive 12, so that the product of the two factors over here must be equal to positive 12, and the sum of the two factors over here must be equal to the coefficient of x. In this case, it's negative a. Okay, now let me try the two factors, negative 1 and negative 12. Okay, and also I can try positive 1 and positive 12. So in the first pair, I have taken both the factors negative. So because when I multiply this negative and negative, it will become positive. 1 times 12 is 12. The second pair, I have taken both the factors are positive, because positive times positive will become positive. 1 times 12 is 12. Okay, so in the first pair, I have taken negative sign for both the factors. In the second pair, I have taken positive sign for both the factors. What if I take one factor as positive and other factor as negative? Let me see, positive 1, negative 12. So when I multiply these two factors, will I get this positive 12? No, because when I multiply this positive and negative, it will be negative, but here we have positive. So in this case, since a constant term over here is having positive sign, so either both the factors must be positive or both the factors must be negative. So we cannot have different signs, like one factor is positive and other factor is negative. Okay, now let's consider the pair where we have two factors. Both the factors are negative. So in this case, when I multiply negative 1 and negative 12, I'm getting positive 12. So when I add negative 1 and negative 12, I'm getting negative 13. It has to be equal to the coefficient of x in the quadratic equation. The coefficient of x in this case is negative a. Okay, if I multiply both sides by negative 1, so what will happen? If I multiply negative 13 by negative 1, it will be positive 13. If I multiply this negative a by negative 1, it will become a. So when I take both the factors as negative and I'm getting the value of a as positive, that is positive 13, it meets the condition given in the question, that is a is greater than 0, that is positive. So when both the factors are positive for positive 12, so we get a positive value for a, it means the condition given in the question, that is a is greater than 0, that means positive. Okay, what if I consider a pair of factors where both the factors are positive? Let me see. So now when we multiply positive 1 and positive 12, I'm getting positive 12. When I add them, positive 1 and positive 12, I'm getting positive 13. It has to be equal to the coefficient of x, that is negative a, according to the method we use to solve a quadratic equation by factoring. So whenever we get two factors over here, the addition of these two factors always must be equal to the coefficient of x. Okay, now let's solve for a in this equation. For that, what I need to do is I have to multiply both sides of the equation by negative 1. So because my aim is to get just a, but here we have negative a. When I multiply positive 13 by negative 1, it will become negative 13. When I multiply this negative a by negative 1, it will become just a. So when both the factors are positive, I am getting a negative value for a over here, that is negative 13. It does not satisfy the condition given over here, that is according to the question, a has to be greater than 0, that is positive. So like in the work what we have done so far, it is very clear. So always we have to get to negative factors for this positive, so that the value of a will be positive according to the condition it is greater than 0. Okay, now I have to list out all the pairs of factors for positive 12, so that both the factors are positive. Already I have written negative 1 and negative 12. Now I can write negative 2, negative 6. Then I can write negative 3, negative 4. Okay, so in each case, if I multiply negative 1 and negative 12, I'm getting positive 12, and negative 2 and negative 6 are multiplied, I'm getting positive 12. When I multiply negative 3 and negative 4, I'm getting positive 12. Then I cannot consider negative 4, because if I consider negative 4, I'll be getting negative 3 over here. Already we have taken the same two factors over here. So negative 4, negative 3 cannot be taken. So negative 5 will not work, and negative 6 can be taken. But if I take negative 6, the second part will be negative 2. But already we have taken the same two factors over here. So negative 7 will not work, negative 8 will not work. Anyway, so that's all. We get three pairs of factors over here for positive 12. Okay, now let's add the two factors on the first pair, negative 1 and negative 12. I'm getting negative 13. It has to be equal to the coefficient of x in the quadratic equation, that is negative a. And let's add the two factors in the second pair, negative 2, negative 6, it will become negative 8. It has to be equal to the coefficient of x, that is negative a. Let's add the two factors in the third pair, which is negative 7 equals to negative a. Okay, in each of these three equations, we have to multiply both sides by negative 1 so that negative a will become positive a. So when I multiply this negative 13 by negative 1, it will become positive 13, and here we get a. And if I multiply both sides of this equation by negative 1, I'm getting 8 is equal to a. In this one, if I multiply both sides by negative 1, I'm getting 7 equals to a. Okay, now I got three possible values for a. But the question is asking us to find the smallest possible value of a. So the smallest possible value of a is 7.